Good day, viewers. We are now going to start our series on quadrilaterals. Now, this series will be consisting of a number of videos. As you have seen, all our previous subjects consist of a number of videos. Because we like to go a little bit slow and as well as explain the underlying fundamentals, because I think if your fundamentals are clear, then you would be able to solve any problems. The same is true for quadrilaterals. So this would be our quadrilateral, quadrilateral. This will be chapter 8 and of NCERT book for class 9. You know, we are only talking about class 9 because I think class 9 is a stepping stone, and if you are very careful, very thorough about whatever has been taught or whatever is in the book, you should be able to go to higher classes. Not only that, because these principles what you are learning here would be also utilized further. Okay, so first we'll start with quadrilateral. Quadrilateral means an area covered by 4 sides. So first of all, this area would be closed. So this is closed, and that is indicated by what is known as covered. COVERED. इसमें एक ज़्यादा एक्स्ट्रा कैसे आ गया? COVERED. Covered. Covered by 4 sides. Okay, so this is an enclosed area. So let us see. So I need 4 sides. Okay, one, I can have this, I can have something like this, and I can have something like this. So let us see. 1, 2, 3, 4. Call it A, B, C, D. I can also have an area which is like this. Like this. So this is also A, B, C, D. Now, one of the problems with these kinds of figures, even though they are quadrilateral, because they are 4 sides, they are not very easily amenable for measurements. So they many times are called, so there are 2 distinctions. One is irregular and other is regular. A quadrilateral. So these are 2 things. So best thing what is engineers and others are used, they are more conversant with regular quadrilateral. Regular quadrilateral. Quadrilateral. So we will be working with regular quadrilateral. What they do with irregular quadrilateral? With irregular quadrilateral, they convert into regular quadrilaterals. So, or regular figures. For example, this may not be a quadrilateral which I want to handle, but I can easily convert it into 2 triangles, and I can easily utilize to measure or do something here. So in case of a regular parallelogram, what quadrilateral, what did they first said? That they said let the sides be parallel. So these 2 sides, why they need these 2 sides parallel? Because they are utilized for roads, they will be utilized for construction of houses, and also for measurements of areas, because you know there are many times there will be between two neighbors, between two neighbors, there must be some dispute regarding their areas. So there also they wanted something which is little bit regular. Okay, so we have taken two sides. Now what we do, can we now talk about another two sides? So this is takes about two sides. So this is two sides which are parallel. And then they said, let us take the other side also parallel. Okay, so this is parallel to this side. So let us call it names. So let us call it A, B, C, D two sides, and PQ and RS two sides. Okay, area covered between these two sides, that is called, that means this area is called a quadrilateral. This area is called a quadrilateral. Quadrilateral. Okay, done. This side is called a quadrilateral. Now, once this has quadrilateral, they started calling it by a different name. They started calling it as a parallelogram. Parallelogram. Okay, now, so the name parallelogram came here, and this parallelogram are designated by, you write two lines which are parallel and then write gram. This is universally accepted and you can use anywhere you want it. There is nothing. So remember, in future we will be all using this as a, and when we want to talk about quadrilateral, this we will say as a quadrilateral, indicating four sides. So these are abbreviations. Everybody uses abbreviations. There is nothing wrong in doing it. Now we know this is a parallelogram. Now depending upon the shape of the parallelogram, they are called differently. For example, let us say here you have parallelogram, right? So okay, depending upon a shape, you will call one, you will call rectangle. Now let's spend a little bit of time in rectangle. What is a rectangle? Rectangle is again two sides parallel. Okay, now there are two sides are parallel. And another one angle here, this is 90 degree. As I will show you later, that one angle being 90, it will land up all angles being 90. It will come out. So a rectangle, you have two parallel sides and you have one of the angles equal to 90 degree. And it will also be shown that the sides, say AB, CD, they are also will be equal. AB will be equal to CD, AB will be equal to CD, and AB will be equal to CD, and AD will be equal to BC. AD will be equal to BC. So this will be, later on we will prove. First of all, now we will say this is like this. Okay, now second one becomes, again on the shape, second one becomes a square. What is this in square? In square, all the sides are equal. AB equal to CD equal to AD equal to BC. All the sides are equal. That means this, and this thing. Definitely. The properties of these properties are transferred here. Only that there is slight change in there. That means these angles are again remain as 90 degree, this angle will be 90 degree, this angle will be 90 degree, this will be 90 degree. Okay, after square, then comes what is known as rhombus. Remember, the properties are not, nothing is changing, on the shape is changing. Here what I have done, what has been done, all the sides have been made equal. Other properties remains the same. Here, what has been done, here these are again the same properties are underscored. The same properties are there. That means the sides are all equal. A, B, C, D, you will find the sides are all equal. And what you will do, but the angles are not 90 degree. So the angles not 90 degree. Other properties are transferred, as you will know, that the opposite angles are equal and all that kind of there, but their angles are not equal to 90 degree. This is called rhombus. There is a very interesting this thing between these two. Now let us take a rectangle between this and this also. If you take a rectangle, say I have taken a rectangle, right? And let us say this perimeter is, this is equal to 3 centimeter and this is, let us say, this is equal to 9 centimeter or any other. You can take it 8 centimeter or all that. Okay, no, my hand, okay, fine, I can utilize this. Let us take this distance. Now what I will do, I will now take this 9 centimeter, okay? That means the distance will be this. So I'll draw an arc, okay? So let us say this is the arc, okay? Setting here, I will take this and I will also draw here an arc, okay? So this arc will be also moving around like this. Moving around like this. Now, let us do one thing. So any distance on this arc will be 9 centimeter. So let me draw the join this. So this is A, B, C and D. Okay. So this should also be 9 centimeter. And if I join something here on this arc, that will also be 9 centimeter. Okay, let me join these two. So what is this? From a rectangle, I have converted into a, you can say this side and this side is equal and this side and this side is equal. But in case of this rectangle, this angle is not 90. So if I call this angle A1, angle 1 is not 90 degree. But look what happens to the area. What is the area of the rectangle? Rectangle area will be equal to 9 into 3. That is equal to 27 centimeters square. Okay, if I have taken. What will be the area of this figure? What will be the area of the figure I am going to sketch now? I'm going to show you this one. I'm going to hatch it. As I have told you before, I like hatching. So what will be area of this particular one? If you see, I can divide this area into two triangles, right? I can divide this area into two triangles, right? Here, two triangles, this triangle and this triangle. So area would be equal to 2 into 3 remains the 3. But this distance I will call, let us call it BD. this distance into CD. Okay, now you can see CD is much less, this distance CD is much less than 9 centimeter. This is much less than 9 centimeter. So let us say this will be something like this CD 2 into 3. I have said CD will be about, let us say I am not able to measure, but if I measure this, it will be less than at least by a centimeter, so it will be less than 8. Okay, so 3 into 8, so multiplied that, so this will be much less than this area. Okay, so this will be about, this 2 is not necessary here, this will be about 24 centimeter, because this is 2. Okay, let me explain this, why this is not necessary. Into half, the area of a triangle is half base into altitude. So these two and this 2 will cancel, and you will land up into 3 into area, that is 24. So 24 is less than 27. Is that okay with you? And you can see this happening. You can see this happening in a sweetmeat shop. You will find that the burfis are always cut in this way. They are always cut in this way. Why? Because this is burfis are always cut in this size, this shape, in this shape. Burfis are always in this shape. Why? Because you can accommodate more burfis in a tray. Okay, so this is interesting. So I made it into 2. So see this, I made it into 2. So the area of a triangle half, base into altitude. So this is base has remained the same. Altitude you can definitely see it is less than 9. So this is 8. Landed up, you're having it as 24. Okay, so we have explained to you what rhombus is about. There is another thing, that next one after rhombus, trapezium. What does that figure show? It says any two sides are parallel. Any two sides are parallel, but other two sides not parallel. Okay, this is trapezium. So you can see, if I want to find out the area of a trapezium, what do I have to do? I have to now make it into 2. So I can use this one like this, and this cut it into this. So this becomes, one becomes rectangle. So this will become a rectangle, and these 2 will be 2 triangles. This will be 2 triangles. Okay, this is how you will handle a trapezium. So these 2 sides are parallel. Okay, now there is another variation of a trapezium, that is called isosceles trapezium. Here the 2 sides are parallel, and these 2 are not parallel, but these sides are equal. So we can say the sides are equal. So these sides, let's say A, B, C, D, AD is equal to BC, and AB is parallel to BC. Okay, this is how the whole system will look, this thing will look like. There are all, this is parallelogram, this is triangles, this is square, this is a rhombus, this is a trapezium. Okay, there is another one. I will use this side of the board in order to show it to you, and they are not. That is called a kite. What does it looks like? This looks like this one. Okay, this is A, B, C, D. AD equal to AB and CD equal to CB. Okay, now this position is, I will do it as 5, and this is called a kite. There is not much application of a kite, but anyway, if somebody tells you how to find the area of a kite, don't get scared. You join these two, so these forms again two triangles, and you will be able to obtain their areas. Okay, but they are not, you cannot say exactly it's a parallelogram, because it is not a parallelogram. So I should not write this one as a part of a parallelogram. I will just say identify it as a separate entity, which should be technically correct, because the opposite sides are not parallel. Okay, only you can say that the opposite sides are equal, because instead of drawing it in this fashion, I could have also drawn it like this. Instead of this, B is here and D is here. So you will not be able to see it. Why it is called kite? Because it looks like a kite. You can put this thing, and you can put this thing on here and use it as a kite, flying a kite. So that's why it is known as a kite. But it is a separate. We do not want to take it in a rectangle or a square or a rhombus or this thing. This is not strictly a parallelogram. Okay, now let us go through some of the properties. Okay, there are many other things which we have to identify in a parallelogram or a quadrilateral. Let us draw that. Let us draw a quadrilateral and identify those definitions. So let this be a quadrilateral. No curvature. Let this be a quadrilateral A, B, C, D. One, it has got 4 vertices. 4 vertices. A quadrilateral. A quadrilateral. I will use these symbols. A quadrilateral has 4 vertices, right? 2, 4 sides, okay, and so 3, 4 angles, okay. It has got 4 angles, A, B, C and D, 4 angles. Angle A, angle B, angle C, angle D. 4 sides. 4 sides, let us define. AB, BC, CD and DA. Okay, so these we will do it. Okay, now AD and BC are called opposite sides. Okay, and they are called opposite sides because they are opposite to each other. This is opposite to this one and this is opposite to this one. AD and DC, AD and DC are adjacent sides. So we will be frequently using this. We will be frequently using this. And second, so this is 3, this is 4 angles, this thing, this is 4, and this is 5. These are the nomenclature. So before you start doing any sums on quadrilateral, please understand this very, very carefully. If you need to understand this, otherwise in a question they will say adjacent sides or they will say opposite sides. You will not know which one is an adjacent side or which one is this thing. Now in order to being an adjacent sides, the two angles, okay, they have a common. Two sides should have a common vertex like AD and CD. The common vertex is D. AD and CD are adjacent sides. Similarly, AB and BC are also adjacent sides. Okay, so this much is now clear. They should have a common vertex, right? Okay, now if you can also talk about something like adjacent angles which have got one side, one arm of the angle. So adjacent angles are, adjacent angle, said angles have one common arm. So you see this angle, okay, I must add here also something, that not only AD and BC, AB and CD, AB and CD are also opposite sides. Okay, this is done. This is mostly we have been able to do it. Now let us do little bit operation. Let us join opposite vertices. Okay, if I join opposite vertices, then AC and BD are called diagonals. Okay, where we have heard about diagonals, we have also heard about diagonals in case of a circle. We call these also the chord passing through the center is called a diagonal. The spelling is same, but because they are joining opposite sides, the same name has also been used. I don't know who has started first. Either they have used in case of circle, or circle was developed first and they have used it. But the spelling is name, and these two are also called diagonals. So don't see the figure, don't get confused. Arey, ye to diagonal kabhi nahi suna tha. I have never heard of it. I have heard diagonal only in case of quadrilateral. No, the same diagonals also come in case of circles. Okay. Now let us go a little bit further on this. So we will start with a rectangle. Okay, we will always draw rectangles like this, but rectangle can also be like this. Rectangle can also be like this. Can also be like this. So they are rectangles. Okay, we will try with, generally this is being very convenient, so that's why we will either stick to this figure or either stick to this figure. Okay, so let us call this diagonal A, B, C and D. Okay, it is also said, it's now we will go through the first properties of the diagonals. First of all, we will follow the book and we will go to angle sum properties. So this is 8.2, angle sum properties of a quadrilateral, let us say, of a quadrilateral. Okay, in order to do that, first of all, let of a quadrilateral oblique A of a parallelogram. Let us say sum of angle sum properties of a quadrilateral. Okay, it's a quadrilateral. Let us take. So this is a quadrilateral. It can be also taken this shape, or you can take this one. Okay, let me try this shape so that you should not think that it cannot happen for any one of the quadrilaterals. So let me take a quadrilateral actually. So of a quadrilateral, and I will remove this, or I will use this one as a quadrilateral, and I will remove this parallelogram of a quadrilateral. So let A, B, C, D be a quadrilateral. So A, B, C and D. What do I have to do? As I have earlier also in one of my videos I said, that you can split a quadrilateral into two triangles. I have shown many polygons can be always converted into two triangles. In triangles you can convert. So let us take now the properties of the triangle. So it's triangle 1 and triangle 2. So what is triangle 1 is? Triangle 1 is which one? Is A, B, D. So let me now, as I do usually, let me write down the angles notation. 1, 2, 3, 4, 5 and 6. There are two triangles, so there should be 6 angles. Okay, I can write angle 1 plus angle 2 plus angle 6 is equal to 180. Why? Sum Why? Because a sum of interior angles of a triangle. Okay. Okay, this is triangle BDA. So let us take a triangle 2. Triangle 2, which is BCD. I have started with A. A's corresponding would be C. No, I can start with B. B, C, D. Then I can also write down here angle 3 plus angle 4 plus angle 5 is equal to 180 degree. Okay, again sum. Why? Sum of interior angles of a triangle. So let's call this one 1, I, and let us call this one 2. Here I will do what? I will add 1 and 2. So if I add 1 and 2, what I will have? Angle 1 plus angle 2 plus angle 6. Okay, from this plus angle 3 plus angle 4 plus angle 5. So there are 6 with this thing is equal to 180 plus 180, that is equal to 360. This is done. Okay, angle 5 and angle 6. So angle 1, angle 2 and angle 3. Angle 2 and angle 3. So the angle 1 is angle A. Angle 1 is angle A. Angle 2 and 3 is what? Angle B. Angle 4 is C. Angle 4 is C. Angle 5 and angle 6. Angle 5 and angle 6. Angle 5 and angle 6. That is equal to angle D. So that is equal to 360. Okay, so the angle sum properties of a quadrilateral is 360 degree. It is necessary to remember this. Amra stop korte pari ekhone ekটু. We will go for the next properties of a. This time we will go for a parallelogram. In case of a parallelogram, we will take 2 sides which are parallel and all these sides which are parallel. So here what we will do, we will call it A, B, C, D. I have drawn it little bit further so that you can see they are parallel lines. So here is a parallelogram in which it is given AB is parallel to CD and AD is parallel to BC. Okay, what we are going to prove that again we will show you how to prove these triangles, they are parallel. How do you prove that? Okay, let us draw these diagonals. Join BD. That is the diagonal. Okay, now we'll prove. We'll prove. Why we want to prove? We'll show it later. We want to prove triangle ABD is congruent to triangle BDC. Okay, now, okay, we can, corresponding we can also take, let us call it CDB, CBD, let us call it CBD, because let us take opposite on this thing. Okay, now in order to prove this, we have also know that AB is equal to, these are parallel, so this angle AB is parallel to CD. AB is parallel to CD, and I will extend this one is further so that you know this BD is transversal. So BD is transversal. Therefore, okay, again number them. 1, 2, 3, 4, 5 and 6. Therefore, we have said what? AB is parallel to CD. If that is parallel to CD, then angle 2 is equal to angle 5. Okay, so this is 1. Okay. Now let us go, and this is included here. This is included here. Okay. Now let's do. AD is parallel to BC. AD is parallel to BC. Again BD is the transversal. Again BD is the transversal. Therefore, we can say angle, now AD is parallel. So this would be angle 3 is equal to angle 6. So we have got now in two triangles. Let us say two triangles. What is that? The two triangles? ABD, triangle ABD, and triangle BDC. Or we have taken, what do we say? We are going to take triangle CBD. We have already proven angle 2 is equal to angle 5. We have also proven angle 6 is equal to angle 3, and BD is common. BD is equal to BD. This is common. So triangle ABD is congruent to triangle CBD. Okay, what does 2 gives us? This gives us, we can say, since they are, we can say AB is equal to CD, AB equal to CD, AD is equal to BC. Okay, so we started, they are parallel. Now we have proven that in this thing, if they are parallel, these two sides are also equal. Now let us take another small things. Here it will be another one. Let us say we have taken angle 2 is equal to angle 5, and then we have taken angle 3 is equal to angle 6. Add them. This is 1, this is I, and this is 2I. So I have 1I here. This is 1I, and this is the other one is 2I. So if you add, then this becomes angle 2 plus angle 3 is equal to angle 5 plus angle 6. So this is angle 2 and 3, this is angle B, this is equal to angle D. So opposite angles in a parallelogram are equal. Therefore angle A is also equal to angle C. So we will stop it here, and we will continue our this thing on parallelogram as we go along. This will be our part 1, and we will be putting up part 2 soon. I will again request you to kindly like my channel and kindly like my channel, and also this video. In the channel you have to subscribe. Please subscribe so that it reaches to many students. Okay, thank you.